The next thing now is product rule. For product rule, suppose u of x and v of x are function of x respectively, then the differentiation of their product will be y equals to u of x. The differentiation of the product y equals to u of x times v of x is given as dy du, dy dx equals to why did I write dy dx equals to u dv dx plus v du dx. So I'll be treating just two examples that has been stated here, and then you can then practice more question at your end. So let's do this. Our y here is equals to 3x raised to the power of 4, then sine x. Remember that for product tree we are considering two functions, function u of x and v of x. So we can split this as a function, we can also split this as a function. We can take this as a function, we can also take this as a function. So if we are taking this, let's say this is our u of x and this is our v of x. So now your u, which is what, 3x raised to the power of 4, if we differentiate u with respect to x, what do we have? We have 3 times 4 x raised to the power of 4 minus 1, right, which is 12x raised to the power of 3. Then let me split this like I managed the book. You have your v to be sine x, and derivative of sine x is what? Cos x. Sine x is cos x. It's cos x. So now we'll go to the now what next is we will substitute these derivatives into the formula for finding the derivative of two product of functions. So, and the formula for finding the derivative of two product of functions is this, which is dy dx equals to u dv dx plus v du ds. You can see that we've been able to find all the parameters that is needed for us to get derivative of product of two functions. We already have our u, our du dx, our v, and our dv dx. Those are all the things that we needed here. So now the next thing is we'll just substitute those known values. For our u is what? 3x raised to the power of 4 times our dy dx is what? Our dv dx rather. Dv dx is cos x plus our v is what? Our v is sine x, and then our du dx is 12x cubed. So with this we can say that our dy dx equals to 3x raised to the power of 4 cos x plus 12x cubed sine x. If you want to factorize common terms out, you can see here 3x cubed can go in these two terms. You can factorize 3x cubed out. If you factorize 3x cubed out, what do you have left? This, you'll be left with s cos x here, and then you'll be left with 4 sine x here. And that gives us the final answer for that question. Another example, which is example 2, we have our y to be equals to e raised to the power of 2x cos 3x. So we can say that this is our u and this is our v. Our u is e raised to the power of 2x. Our v is what? Cos 3x. You will see that our v is a function of a function. Yes, it's a function of a function, because cos 3x can be written as a function of u, and then u will now be a function of what? Function of x. So let's first of all treat this one. Let's do this one. If we differentiate u with respect to x, what do you have? Remember I said first of all you differentiate what you have as the power of the exponent here, which is 2x. If you differentiate 2x, what will it give? It's going to give you 2, and then write the whole of the what? The expression that you want to differentiate. So that's the differentiation of what? An exponent of 2x. Then for dv dx, since dv dx since v is a function of a function, what do? First of all, assume that 3x is u. When you assume that 3x is u, so cos u will give you what? Minus sine u. That's minus sine 3x, right? So you find the derivative of cos 3x, which is what? Minus sine 3x, and then you will now differentiate 3x itself. If you differentiate 3x, what do you have? That's 3. So this is going to give you minus 3 sine 3x. So like I said, this is a function of a function. You can, okay, let me just do it here for clarity. Let's say my y is equals to cos 3x. So if I say, okay, let my u equals 3x, my y will become what? Cos u, right? So my dy du will be what? Minus sine u. There is a minus here. And if I differentiate my u, du ds will be what? Equals to 3, right? So by the time I find dy ds of cos 3x, what will I have? I will have dy du times du dx. And what would that give you? Dy du is what? Dy du is 3, du dx is what? Dy du is minus sine u, and du ds is what? 3. So your final answer is minus 3 sine u. Remember, you have named your u to be 3x, right? So eventually you see that minus 3 sine 3x. This is a function of a function. And you can see that the result that we got here is not different from what we have here. So now that you have known your du dx and your dv ds, you can easily substitute those values into the given formula, which is u dv dx plus v du dx. So with this now, your dy dx will be equals to, what's our u? E raised to power of 2x. What's our dv dx? Dot dv dx minus sine, minus, what is that? Minus 3, let me put a dot here because of space. So minus 3 sine 3x plus, what is our v? Our v is cos 3x times, what is our d ds? D ds is 2 raised to power 2x. So eventually we can rearrange such that this will become okay, we can even factorize e raised to power of 2. Okay, no, wait, let me first of all finish this one. So this will be minus 3 raised to power of 2x sine 3x, and this will also be what? 2 raised to power 2x cos what? Cos 3x. So e raised to power 2x is common. If I factorize e raised to power 2x out, what am I going to have left? I'm going to have 3 sine 3x minus 3 sine 3x plus 2 cos 3x. So that's our final answer. E raised to power of 2x bracket of minus 3 sine 3x plus 2 cos 3x. You can try these exercises. You can practice these exercises, which are determine. So our exercises now. What did I write? So you can practice these two exercises at your end. You can practice these two exercises at your end. So the next thing on our list now is quotient rule. After discussing quotient rule, we are going to end the first session on that differentiation and its application, and then we'll be looking forward to our next class. Thank you.